Welcome to 6.2, multiplying and dividing rational expressions. We're going to be multiplying rational expressions and simplifying them. We're also going to be dividing rational expressions and simplifying them. So it's important to know how to factor to move on to this section. So let's say we wanted to multiply rational expressions. Now remember, rational just means fractions. So we're going to multiply polynomials that are in the numerator and in the denominator. So we multiply them like we normally would fractions. A lot of the times you might hear me say tops times tops, bottoms times bottoms. That just means multiply the numerators and then multiply the denominators. Okay, so let's look at our first example. I'm going to write it out the long way at first, and then towards the end of the video, I won't be writing every single problem the long way. So we have the numerator of our first fraction, 4x cubed y, and we're taking that times the numerator of our second fraction, negative 6x squared y squared. And in the denominator, my first denominator is 3xy to the fourth, and I'm multiplying it times 10x to the fourth. Okay, so this is the long way. This is what my rule up here is talking about. My u times my w, my v times my z. Now u, w, v, and z just represent either numbers, variables, or even algebraic expressions. So like in this problem, I'm multiplying algebraic expressions. So if I'm going to do this, it's important to remember my power rules. Well, we can multiply coefficients just like we would normal numbers. So 4 times negative 6 is just negative 24. Now we want to look for variables that have the same base. So these powers that have the same base, look at x. I have x cubed times an x squared. Remember, when we multiply exponents, when we multiply powers, we add their exponents. Remember, x cubed times x squared is just the same as 3x's times 2x's. That means there are 5 here. So we have negative 24x to the fifth. Now let's look at our y's. I have y to the first times y to the second, so I'm going to add those exponents and get y cubed. The denominator, 3 times 10 is 30. And I have 5 x's listed there, 1 in my first denominator and 4 in my second denominator. And I have y to the fourth multiplied by no other y, so there are still 4 y's. This isn't quite simplified. Remember, I can see where are there more and how many more are there. Also, I can simplify the fraction negative 24 over 30. Well, 24 and 30 are both divisible by 6. So 24 divided by 6 would give me 4. And 30 divided by 6 would give me 5. Now I need to look at my variables. Where are there more and how many more are there? Well, I have x to the fifth in the top and x to the fifth in the bottom. So there are no more x's, they divided out. However, the y's, I have 3 in the top and 4 in the bottom. So there are more in the top and there's 1 more. So I have y to the first in the denominator. And if it's to the first power, I don't have to write the 1 with it. So my simplified multiplied rational expression is negative 4 over 5y. If we were concerned about listing the domain, it would be x cannot equal 0 and y cannot equal 0. So obviously the y cannot equal 0 came from the denominator here. The x cannot equal 0 came from my simplified denominator, my multiplied denominator. This x right here cannot equal 0. It would turn my whole denominator into 0. But if you've talked to me about 6.1, we know that we aren't really concerned with our domain because WebAssign Homework puts it in for you. My main concern is that you understand how to multiply these rational expressions and get the simplified version. Let's look at the next example. Now, this may not look like two fractions, but really it is. Remember, this can be written as a fraction over 1. So I'm going to multiply my numerators. I have 8 times 9 plus 12x. And in the denominator, I have 3 plus 4x times 1. Well, anything times 1 is just itself, so I'm going to leave it as is. Now, when I multiply my numerator, I'm going to make sure my 8 gets distributed to both terms. So 8 times 9 and 8 times 12x. I could do that. However, my end goal is to have a simplified version. So instead of distributing like it may look like I want to do, I actually want to factor a common monomial out of the 9 plus 12x. Remember, I'm trying to get things to cancel like I had my x to the 5th cancel in the first example. All right, so I still have my 8. And a common monomial between 9 and 12x, I could factor out a 3. So if I factor out a 3, then I'd be left with 3 plus 4x. This is awesome. Look at my denominator. I have a 3 plus 4x down there. So when I cancel, I simplify the 3 plus 4x, and I'm left with an 8 times 3 over 1. This simplifies to just 24. So at first it may look like you want to distribute your 8. However, remember it's easier if we can match up things in the numerator and the denominator that cancel out. Multiplying rational expressions continued. So this is more practice of the problems that you're going to see on WebAssign. So if at any point you want to pause the video and practice it on your own, play the video and see if you get the same answer as I got, that is a great idea and an awesome way to practice your skills. So I'm going to continue to do this one. In the numerator, I would have x times x minus 4. And in the denominator, I'm going to write it out as factoring each set of denominators. So instead of multiplying these and distributing, I'm going to actually factor. So looking at our first denominator, what could I pull out of 5x squared minus 20x? Well, they have a 5 in common, and they also have an x in common. When I pull out a 5x, I'm left with 1x minus 4. Now, looking at the other denominator, I'm going to factor it. 2x squared plus x minus 3. This one's a little trickier to factor. So let me go and write over here how we're going to factor this denominator. Okay, so I have a number 2 in front of my x squared. That's what makes this a little tricky. I'm going to factor by grouping. So this was a Chapter 5 skill. You all should be able to do it. If not, let's think about how we did this. So we look at our a times our c. Our a is 2 and our c is negative 3. So when I multiply that, I get negative 6. I also want to look at my b. b is the number with the x. The number is positive 1. So what we did in Chapter 5 was we looked at the factors of negative 6 that add up to 1. The two factors that add to 1 and multiply to negative 6 would be a negative 2 and a positive 3. When I multiply them, I get negative 6. When I add them, I get positive 1. So these are the factors that I want to use to rewrite my middle term, rewrite my x. So how should I rewrite it? Well, my first is still the 2x squared. And instead of writing plus x, I'm going to write minus 2x plus 3x. Remember, those came from the factors. And lastly, I have this minus 3. After we rewrote this problem, remember this is the second denominator, we factored by grouping. So my 2x squared minus 2x was grouped together, and my 3x minus 3 was grouped together. Now, after you group, you have to look to pull something out of both of the groupings. So I can take out a 2x from the first grouping, and I'd be left with x minus 1. And I can take out a 3 from the second grouping, and I'd be left with an x minus 1. As soon as you notice that there are two x minus 1s, go ahead and factor out an x minus 1 from both. If you take out an x minus 1 in the first group, you're left with a 2x, and in the second group, you're left with a 3. This is the factored form. So this is my next part with my denominator. Remember, this was the first denominator factored, and this came from the second denominator factored. Now that I have factored both of them, I'm going to look what matches in the numerator and in the denominator. Obviously, I have the x minus 4s that cancel, and the only thing left in the numerator is an x. So if I cancel him out here with this guy, I'm left with this imaginary 1 left in the numerator. So my final factored form would be 1 over 5 times x minus 1 times 2x plus 3. This is as simplified as I can get. I'm not going to worry about my domain, but if you'd like to have it in your notes or you tried to figure it out, it would be x cannot be 0, 4, 1, or -3/2. If you're really interested in why this is your restricted domain, please come ask me a question. Okay, the second one on this page. Let's start by factoring. So I could write it out the long way like I did in the first two examples. In the first example, I wrote the first numerator times the second numerator, and then I multiplied them and factored out. Well, here, I'm not going to do that. It just takes an extra step. So let's start by factoring our first numerator. I can take out a 4x, and I'm left with an x minus 1. Second numerator factored. It's a trinomial, so I'm going to factor into two sets of parentheses. Remember, I'm looking for two numbers that multiply to -6 and add up to 1. Those two numbers, again, would be -2 and +3, and x goes in the first position. Now my numerator is factored, I want to look at my denominator. I have another trinomial, so again, trinomials get factored into two sets of parentheses. What two numbers multiply to -3 and add up to 2? That would be a -1 and a +3. And I have a 4x, which cannot be factored in the denominator. So now that I've factored, I want to look for pairs that cancel. Obviously, my 4x will cancel with the 4x, x minus 1 and x minus 1, and an x plus 3 and an x plus 3. So lots of things canceled. The only thing remaining is an x plus 2 in the numerator. Remember, there is an imaginary 1 in the denominator, but I don't have to write that. This is my answer. Again, if you're worried about the domain, it's x cannot equal 1, it cannot equal -3, and it cannot equal 0. Again, if you have questions over that, please ask me, but WebAssign is not going to make you type in the restricted domain. If you like to leave yourself little notes, remember this top one we factored out a common monomial. And in these two, we factored the trinomial. So chapter 5 is highly, highly important for you to be able to multiply and divide rational expressions. Okay, one more example on multiplying. Now this has both variables. It has two variables, an x and a y. And in the previous slide, it only had x's. So you might want to leave yourself a little note that this is two variables. So when you get to your test or homework, you know to come to this slide. Okay, so two variables. I can't factor an x plus y anymore. So he's still in my numerator. Now looking at the second numerator, it looks like a binomial, but it's kind of in a different form. This can actually be factored, since it's a trinomial, into two sets of parentheses, just like we did on the last problem. I know that my first numbers, so when I FOIL my first, it has to equal an x squared. So an x times an x is the only thing that would get me that. So x has to go in my first position. Now look at your last term. It says negative 2y squared. Well, that means that when I multiply my last two numbers, it has to equal negative 2y squared. So I know there's got to be a y in both, because y times y will get me y squared. Now the number that's going to get me negative 2 is only one option. It's got to be a negative 2 and a positive 1. So I can put negative 2 here and a positive 1 here. No other numbers, when I multiply them, will give me negative 2. That's how I was able to factor this. Ooh, excuse me. Factor this trinomial. I kind of use reverse FOIL. So in the denominator, I have y squared minus x squared. So what is this? Well, this is the difference of two squares. The difference of two squares, if you remember, is factored into two sets of parentheses. One's positive and one's negative. Now, in your first spot goes the first thing being squared. So y is your first thing being squared. The second position is the second thing being squared, which is x. And lastly, my second denominator is 3x minus 6y. Do you see anything that we could take out of there? Well, obviously we can't take out an x because it's not in both terms. We can't take out a y because it's not in both terms. But we can factor out a 3. Taking out a 3 would leave us with x minus 2y. Again, if you like leaving yourself little notes, make a note that this was the difference of two squares. And here we factored out a common monomial. And this was just a factored trinomial. Okay, now that I have both the numerator and the denominator factored, I'm going to cancel out what they have in common. If you notice, I have an x minus y and a y minus x. I also have an x plus 1y and a 1y plus x. So I see some similarities here. Let's see if we can't rewrite this so that more items match up. Well, let's leave this as x minus y and x minus 2y and x plus y in the numerator. Now looking at our denominator, how could I change y minus x to look like x minus y? Well, I can factor out a negative. So if I factor out a -1, that's going to change the sign. That's going to turn my y negative and my x positive. So my x will turn positive and my y will turn negative. Now this looks like it's going to match up. I have a y plus x. Remember, addition is commutative, so I can switch this around. It's the same as an x plus y. And I still have my 3 and my x minus 2y. Now I see some things that will cancel. X minus y's, x minus 2y's, x plus y. When there's nothing left in your numerator, remember imaginary 1. The denominator, I have a -1 times 3. So this is going to simplify to -1/3. If you're still a little confused on how I went from y minus x to x minus y, maybe this would help you. Y minus x, and I'm factoring out a negative. So taking out a -1 would change this to -y and positive x. Well, I can rewrite this with the x first and the y second, and that's exactly what I did here with this blue arrow. If you're interested in the domain, this one's a little tricky. X cannot equal y, x cannot equal -y, and x cannot equal 2y. Again, if you're interested in the domain, please ask and I will help you learn it. And finally, you may see a problem where there are 3 rational expressions being multiplied. Well, we're going to do the same thing. Multiply the numerators, multiply the denominators. So if I'm factoring the numerator, my first one is a trinomial. So gets 2 sets of parentheses. I'm asking myself which numbers multiply to +2 and add to -3. Well, that'd be -2 and -1. So I have x minus 2 and x minus 1. Next, I have a 3x, which cannot be factored anymore, and a 2x plus 4. I can factor out a common monomial. They have 2 in common. So when I factor out a 2, I'm left with x plus 2. Denominator, x plus 2 cannot be factored. X minus 2 cannot be factored. But x squared minus 5x can. They have something in common. They have an x. So factoring out an x would give me x minus 5. After you get the numerator and denominator factored, it's time to cancel. So x minus 2 and x minus 2. I have an x plus 2 and an x plus 2. Now notice I have a 3x and an x. So I can cancel out the x and the 3x and the x with the 1. And now in my numerator, I'm left with x minus 1, a 3, and a 2. The denominator, I'm left with an x minus 5. Remember, I can multiply numbers. So this would simplify to 6 x minus 1 over x minus 5. Domain on this one, x cannot equal 5, 0, 2, or -2. Now dividing rational expressions. So we divide rational expressions just like we would divide fractions. Now remember, when you divide fractions, it's the same as multiplying by the reciprocal. So if I had 5/6 divided by 7/8, the way I solve this would keep my first fraction the same, change division to multiplication, and flip my second fraction. Now, just like I multiplied my rational expressions, tops times tops, bottoms times bottoms, get 40 over 42, and obviously you'd simplify this. So let's try the first example. I want to rewrite this as a multiplication problem. So my first fraction stays the same, x over x plus 3. Division changes to multiplication, and I'm going to flip my second fraction. Now this becomes a problem like we were just solving. I have x times x minus 1. Remember, we're not distributing the x to the x minus 1 because we want to keep it as simplified and factored out as possible. And I have 4 times x plus 3. Now, there's nothing to really cancel, so this is as far as I could go. I can't cancel the x minus 1, an x minus 3, a 4, or an x. If you're interested in the domain, x cannot equal negative 3, and it cannot equal 1. You may wonder where this 1 came from. Well, obviously the negative 3 came from the denominator here. But looking at the original problem, one of our denominators was x minus 1. Well, this can't be 0 because we cannot have 0 in the denominator of our original answer. So that's where the positive 1 came from, if you set x minus 1 equal to 0. Let's jump down to the second problem. I see the division sign, so that I automatically think multiply by the reciprocal. So I have 2x over 3x minus 12 times x squared minus 6x plus 8 over x squared minus 2x. Now, I could have saved myself a step and factored, but I wanted to write it out the long way and show you the multiply by reciprocal. So now that I've rewrote it, I want to make sure I factor this. I cannot factor 2x, but I can factor this trinomial into two sets of parentheses. Two numbers that multiply to 8 and add up to negative 6 would be a minus 2 and a minus 4. In the denominator, my first one, I can factor out a 3 and I'd be left with x minus 4. Second denominator, I can factor out an x and I get x minus 2. As soon as I factor, remember I want to find things that cancel. I see an x here and an x here, those cancel. And an x minus 2 with an x minus 2, x minus 4 with an x minus 4. Don't forget there's still a 2 in the numerator and a 3 in the denominator. So this rational expression, after I divided them, I get 2/3. Domain on this one, x cannot equal 4, 0, or 2. Let's continue this practice. So we have two more problems, this one and the next one. Remember, at any time, you can choose to pause the video and try it on your own. If I rewrote this as a multiplication problem, it's going to be x squared minus y squared over 2x plus 2y. Notice how my first fraction never changes. It's my second fraction that flips. So 6x plus 2y is now my numerator, and 2x squared minus 3xy plus y squared is my denominator. Let's work on factoring. Notice that my first numerator is a difference of two squares. Difference of two squares gets factored into two sets of parentheses. They're identical except one is positive and one is negative. In the first position is the first thing being squared, second position is the second thing being squared. So it factors into x plus y and x minus y. The 6x plus 2y, I can take out a 2, and I'm left with 3x plus y. Let's work on the denominator. First denominator, factor out a 2. and I'm left with x plus y. Now the second one, it looks like another trinomial. If you remember from chapter 5, trinomials get 2 sets of parentheses. And think about this as a factor by grouping, because when you see a number with an x squared, when your first coefficient is a number that is not 1, you need to factor by grouping. So when you do this, you need to look at your a times your c. So I have my a is 2 and my c is the number with y, which is just 1. So 2 times 1 would give me 2. You also need to look at your b. B is the number in the middle, so a -3. What we're looking to do is find factors of 2 that multiply to 2 and add up to -3. Those factors would be -2 and -1. They multiply to +2 and add up to -3. Now I'm using these factors to rewrite this trinomial. I'm rewriting the middle term -3. My first term stays 2x squared, but instead of writing -3, now I can write it as -2xy and a -1xy. The 2 and the -2 and -1 came from these factors that multiply to 2 and add up to -3. And lastly, I still have my plus y squared. After I rewrite, I need to group. Group the first two together. Group the last two together. Make sure the negative stays with the xy. Factor out what they have in common. So in my first set of parentheses, I can take out a 2 and an x because it's in both of them. I'd be left with x minus y. Over here, remember we're hoping to get something that looks like x minus y. So we could actually factor out a y, but furthermore, we could factor out a negative y. When we factor out a negative y, then we're left with a positive x minus y. Remember, factoring out a negative changes the signs inside your parentheses. This is good because x minus y is in both, so I can factor it out. When I factor it out of the first set, I'm left with 2x. Factor it out of the second set, I'm left with a y. Now this is what goes in my parentheses. This is the factored form for the dotted red circle. X minus y, 2x minus y. Now I'm looking to cancel x minus y's, my 2's, and my x plus y. Final factored form is 3x plus y over 2x minus y. Now remember, I can't cancel these x's. If you're curious about the domain on this one, x cannot equal y, x cannot equal negative y cannot equal negative 3x, and y cannot equal 2x. Remember, if this domain part really stresses you out, don't worry about it because WebAssign is not going to ask for it. Some people just like to look at it, they like to have it in their notes, so I want to make sure that you get it in your notes. Okay, one more example. I want to rewrite this, so as soon as you see the division problem, keep your first fraction the same. Think about how you would factor that. Change division to multiplication and flip your second fraction. So 3x minus 21 goes in the denominator. X squared plus 2x minus 35 goes in the numerator. Now that I've rewritten it, I want to make sure I factor my numerator. So my first numerator is a trinomial. I'm going to factor into two sets of parentheses. Two numbers that multiply to positive 49 and add to negative 14 are negative 7 and negative 7. Over here, again, I have a trinomial, so it gets factored into two sets of parentheses. Two numbers that multiply to negative 35 and add up to positive 2 will be a negative 5 and a positive 7. Now that my numerator is factored, I'm going to factor the denominator. Notice that x squared minus 49, nothing can be factored out of it, but it is a difference, and it is two squares, x squared and 7 squared. So the first thing being squared is x. Remember, one's positive and one's negative. The second thing being squared is 7. Second denominator, I could factor out a 3. 3 is what they have in common, and I'd be left with x minus 7. Now that all four rational expressions are factored, I'm going to cancel. X minus 7, x minus 7. There's another x minus 7, and an x plus 7 will cancel as well. The numerator, I'm left with x minus 5. And in the denominator, I'm left with a 3. This is as far as I can go. Restricted domain, x cannot equal 5, 7, or negative 7. So it's very, very critical you understand how to factor, especially difference of two squares, trinomials, and trinomials that have a first coefficient that isn't 1, like we did over here in red. And if you can factor, you're going to be successful in 6.2, multiplying and dividing rational expressions. If you have questions, please ask Miss Eck.